Hello and welcome all. Today we are going to see what is called transformer hysteresis or a core hysteresis. That means take a coil and a core is put inside the core. When an AC current flows through this, if the core has a relative permeability, if we use iron as the core, it has a relative permeability of mu r is equal to around 1200. That means it is conducting flux 1200 times than air. Mu 0 is the conductivity of the air, 4 pi into 10 raised to 7. This is the permeability of the air. That means if 1 ampere current flows through this circuit, this much of flux will be generated. If the air is if there is no core is put inside, this much of flux is generated. But if we put a iron core inside it, it will generate 1200 times the flux that generated by the air. Now we consider what is hysteresis. We apply an AC signal across a core, and if we put an iron core across it, the flux in the core will increase linearly. As iron has this much of relative permeability, the flux will increase linearly. And at this time, the flux has reached its maximum value. And if further current is increasing, the iron is not able to increase the flux anymore because it has no space. That means it is already filled with flux. So it has reached its maximum flux. Now what happens is that when it reaches its maximum flux, the iron has now become a magnetic. This is an AC signal, and during this signal the current flows in one direction, and due to this the flux is increased in one direction and reached a maximum value. And if further the increase in current will not have any effect on the core because the core has already saturated. That means it has already becomes, the flux is reached to its maximum. So now as the flux reached its maximum and the core becomes now a temporary magnet. If we say that this is the south pole and this is the north pole, and it has become a magnet, when the flux in the core reaches maximum, it has become a magnet until the current flows through, it remains the same. It becomes a magnet. We have to check also this, that when initially a current is flowing through this, the current required is very less. That if we say that the average current required to magnetize transformer core is very less because the relative permittivity of the material is high. That means with a small current, large amount of flux is flowing through the conductor. That means if we say that, if we plot a graph, and if it is the relative permittivity, that means when a force is applied, this is the flux generated inside the core. With this force, this much of magnetic force is created in the core. If the relative permittivity is higher, means with the same force more magnetic field is created. That means relative permittivity increases, means the flux generated inside the core increases. When at the starting the flux relative permittivity is very high, that means for a small change in the magnetic force, the force on this side, the flux generated inside the core is very less. But after it is fully magnetized, that means after when the magnetic core is fully saturated, that means the flux is fully filled inside that core, further increase in current will not have any effect on the flux. So it has become saturated and it has become a magnet. If we say that this is the south pole and this become north pole, now after it become saturated and become a magnet, now if we apply a force in the reverse direction to decrease the flux, it will not, the permittivity of the core is not linear now. It is like this. Like this means for the same force, magnetic force, say for the same magnetic field, this is the change in flux earlier. Now for the same magnetic flux, for the same time period, only this much of flux is changed. If the magnetic field is decreased by an amount, by the same amount, earlier it was changed, the flux changes this amount. Now it becomes very less. That means the relative permittivity of the material decreases. That is, a very high change is required for a small change in flux. Due to this force, only the flux is reached there, not to zero. So at the first time, the current through the transformer that is creating the magnetic force is very less because it has a high permittivity. That means for a small current, a large change in flux happens and it will reach the maximum flux with a very less force. Now the permeability of the material, after reaching this point, the maximum flux, the permeability of the material decreases. So this much of amount is not, this much of magnetic field is not able to return this magnetic field to zero. That means the permeability of the material decreases. So more current has to be flown through this circuit. More current has to be flown through the circuit. Then only it will create more magnetic field and so thus able to reduce this flux to zero. So more current has to be flown through this circuit. What is the disadvantage of this hysteresis? That first time we apply voltage and a small current is required to generate the maximum flux. But after it reaching to the maximum point, the current or the power required to current and the power. More current means more power. More current through the coil will generate more force. That means more power is wanted to reduce it to zero. So from the next cycle onwards, more power is wanted. That means at each cycle of the frequency, more power is needed to change. Once if we say that if it has, we have reduced the flux with, reduce the magnetic field with more current, that means more power is applied and it becomes zero. Now at this time the flux is not zero, the flux has some value. So more force magnetic field has to apply. More magnetic field means more current has to apply, that means more power has to apply. Then only it will reach to this point. If the frequency of the input wave is 10 microseconds, that means in 10 microseconds the flux will reach to maximum, and in another 10 microseconds the flux has to reach to the reverse direction. Then the magnetic field become reversed, this become north and this become south. When it is reversed, the pole of the magnet is reversed. If we take 5 microseconds is the time. If we take the time taken to reach the maximum value is 10 microseconds. Is 10 microseconds. So, and again a 10 microsecond you need to reverse the magnetic pole. That means 5 microsecond is needed to become a magnet of, so the pole is south and north here, and another 5 microsecond is needed to reverse its poles. When it reaches there, the south become north and north become south. So the total time period will be 10 microseconds. Frequency is given by 1 by t, that is 1 by 10 microsecond. 1 by 10 microsecond is equal to 100 kilohertz. If we say that the power, extra power we want to overcome the less relative permittivity is, say a 1 millijoule. 1 millijoule is the extra energy needed for one cycle. For one cycle, we need an extra energy of 1 millijoule. So 1 millijoule into 100 kilohertz. 1 millijoule means 1 into 10 raised to minus 3 into 100 kilohertz means 100 into 10 raised to 3. This will give 100 joule of energy. That means 100 joule of energy is needed only to change the magnetic poles. So this is called hysteresis. As hysteresis decreases, less energy is needed. So hysteresis is not a good property of the material. The relative permittivity is not changed even after it reaches to maximum flux. Then with the same flux, the flux in the core will be reduced to 0. This is not happening, so it is not a good one. So this is called hysteresis, core hysteresis.